Welcome to the webinar. You have entered as an attendee in listen-only mode.
For question at the end of the webinar. So about our speaker, Dr. Poo graduated from medical school in 1990, and she has dedicated her most of time to clinical research and investigation on small embryo and fetal brain in perinatology. Especially, she has introduced the most sophisticated fetal neuroimaging from 1996 by using transvaginal. She established CRIF and Clinical Research Institute of Fetal Medicine in Osaka in 2006, with its leading a field of prenatal diagnostic internationally as well as in Japan. Now, without further ado, I will turn the time over to Dr. Poo to start the webinar. Welcome, Dr. Poo.
Thank you very much. I'd like to share my slide. Can you see my slide?
Yes.
Okay. So thank you very much for inviting me as a speaker. And I'd like to share with you today the clinical significance of the 3D HD live series and the flow in the neurosonography and the neuroembryology. And my the COI, I myself is the CEO of Rich Medical Corporation, and that is a clinical genetic laboratory in the same building of Kurihon. Now, the GE has a lot of 3D abilities, and one of the major is HD Live. And here, the left-hand side, you can see the conventional 3D ultrasound. Of course, it is beautiful, and you can see, this is 9 weeks of gestation, and this is the fetus, and the umbilical artery, and the amniotic membrane, and the yolk sac and the yolk sac stalk. This is beautiful, but with HD Live image, you can see, the surface is much more sophisticated. And this is HD Live silhouette image. And with some degree of silhouette image, you can see the more sophisticated, the nice surface. And also you can see the inside of the embryo or fetus. Now, I'd like to share with you several cases in the first trimester, and this is the RE2 first trimester neuroimaging. Here you can see the upper side, upper bar, the doors are the images from the fetus, the CRL 19.3 millimeter, 22.3 millimeter, and 23.9 millimeter. And I tried you to put the focus on here. This small one, this is the small forebrain, the brain, the cerebrum. But the day by day, it is bigger and bigger, like this. So during the early pregnancy, the brain is remarkably and very rapidly developing. And here, this is 8 weeks of gestation, and you can see already the forebrain is divided into the two, the right and left hemisphere, and those are not the hemisphere, that is the lateral ventricle. But here, this is the 8 weeks of gestation, and this is a normal fetal circulation with the small forebrain, midbrain, and hindbrain. And now, this is a very small baby. CRL is 26.2 millimeter. That is minus 3.7 standard deviation. That is a little bit small. but this is the IVF baby. So IVF baby mostly the CRL is compatible to the gestational age. However, this baby was small, and here if you can see, that this is the fourth ventricle, the hindbrain, but here the forebrain, very big, and also it is not separate. And here, maybe that you now know that this is very abnormal baby, and here the left hand side is this baby, and right hand side that this is the normal baby. And if you compare those, you already know that this is the early stage of the holoprosen separate, and because of the triploidy, that is the 69 chromosomes. And here, this is the small case at 12 weeks of gestation. Usually, inside of the cranium, you can see this is the butterfly structure of the choroid plexus, and this is normal. However, this baby, the very small choroid plexus, and this is the very early stage of the ventriculomegaly. And however, in this case, the by CVS, normal karyotype, normal CMA, and later on normal TES, the targeted exome sequence. And but this case, 15 weeks of gestation, this is Syret ultrasound, HD live Syret. And then, the 18 weeks of gestation, this is the extraction of the ventricles. And the 18 weeks, the week by week, that this is the ventriculomegaly was spontaneously resolved. Now, this is the case. This is the vanishing twin. That's okay. But here you can see this is the yolk sac, a little bit bigger than the normal shape, normal size. And this is a very cute baby, with an umbilical cord. And here, this is 10 weeks of gestation from the front. Here you can see, you notice that, that this baby has a cleft lip. However, recently, that this is the HD live, the surface rendering mode, and you can see, the cleft lip at 10 weeks of gestation. However, 12 weeks of gestation, the brain is completely normal. And here, this is 15 weeks of gestation. Again, the cleft lip here, very clearly. And then, from 15 weeks of gestation, the ventriculomegaly was became very conspicuous. And this is 17 weeks. And this is 17 weeks, coronal view. And you can see the very big, the ventricle. And, here you can see this is the choroid plexus. And choroid plexus, this is called as dangling choroid plexus. And because of the high intracranial pressure. And this is 19 weeks of gestation. This is not Syret ultrasound, that this is the conventional mode of the extraction of the ventricles. But, the 19 weeks of gestation, the much more conspicuous enlarged ventricle. So, I can show that, the normal case, the normal delivery from the early ventriculomegaly, but early normal ventricle, but later on the ventriculomegaly. Very, there are various cases, according to, so, you have to look at the baby, look at the fetus, the longitudinally. It is very important thing, longitudinal follow-up scan. Now, this is very small baby at 10 weeks of gestation. Here, there is something, the out from the top of the head. And here, this is the forebrain, midbrain, and hindbrain. Midbrain is a little bit, the conspicuously, of the bigger than the normal size. And this is 10 weeks of gestation. And this is 11 weeks of gestation. And here, this is the cyst, that is continuous to the inside of the cranium. However, there's no brain herniation. And here, 10 weeks, 11 weeks, and 12 weeks of gestation, and 13 weeks of gestation, suddenly the cyst disappeared. However, this is the additional, this kind of this tumor-like thing out of the brain. And 13 weeks of gestation, and 15 weeks of gestation, and this is the baby, that after birth, and everything inside of the brain is normal, and this was rejected that, and the prognosis was very good. Now, the 3D ultrasound, the applications of 3D ultrasound, I would like to introduce the several offline analysis. Okay, and before that, this is the not ultrasound. This is the MRI, but if you look at MRI, if you see this is the stomach and this is the liver, and then you can notice that this is the left side and this is the right side. However, if there's no stomach and no the liver, maybe that some of you think that this is the right side or this is the left side, right? So it is sometimes very difficult to get orientation right or left. And the same thing in the transvaginal 3D sonography. Here you can see if you have the transducer like this, and then there's something wrong. This is the porencephaly. Porencephaly is left hand side. From your vision, and then if you put the transducer here, oh my God, the porencephaly is moving, this side. Okay, so sometimes it happens, and if especially transvaginal sonography, it's very difficult to get the orientation right or left. So we use the 3D ultrasound. If you use the 3D ultrasound, it is very easy to get the orientation. If you, after the acquisition of the 3D ultrasound, and this is the 3 orthogonal view. And if you set the brain, the frontal, the sagittal plane here on the B, and the axial plane on the C. And note that, that on the B, the frontal side is your left side. And, this is the occipital side. Occipital side is on your right side. And, automatically on the A plane, the coronal structure is visualized on the plane A. And here, this is the fetal left brain, and this side is the fetal right brain. Okay, so you can get the easy orientation like this. So if you use the 3D ultrasound here, you can manually rotate the brain, and then this is the right brain of the fetus. Okay? And also, from the single volume data set, there are many kinds of various expression of the 3D ultrasound. Here you can see this is 3D silhouette ultrasound, and here you can see the lateral ventricle. This is the enlargement of the lateral ventricle, and then you can see the Monro, the foramen of Monro, and third ventricle. Okay, So, inside of the brain is visible. And here you can see this is the HD Live, and here this is the choroid plexus inside of the enlarged ventricle, and this is the serial ultrasound from the lateral. This is the lateral view, and here the choroid plexus, and this is the Monro, and here you can see the third ventricle. So it is impossible to look at the third ventricle, in this shape, in the 2D ultrasound, and even the 3D ultrasound. It is very difficult, if you look at just from the outside, it is very difficult. But the serial ultrasound, you can see the third ventricle and the Monro between the lateral ventricle and third ventricle. Now this is the brain, the coronal section, and here you can see we have this image. They use the serial ultrasound with the some of the light. The light technique is a GE only, and that is a very the interesting. It is sometimes the troublesome. It is too much. However, there are several types of the 3 types of the light, the spotlight and the light on the stage. And if you use the door's light, you can make the shadow, as you write. And here, this is the normal brain in the coronal section, and this is the thick slice silhouette. Thick slice means the thick slice, and then we use the silhouette ultrasound. So if you look at the doors are the anterior horns of the lateral ventricle, and this is the hydrocephalus thick slice silhouette mode, and here you can see this is the posterior, this is the anterior part of the coronal section. And this is the Dandy-Walker malformation at 16 weeks of gestation. And this is a very old picture, the 2013. However, this is very good picture, because the lateral ventricles, and this is the fourth ventricle, and inside here you can see the third ventricle is visible. So the all of the ventricular system can be seen by using the serial ultrasound. Now, the volume calculation, brain vascularity, bony analysis is possible. The volume calculation, for example, this is the measurement of the volume, of the intracranial structure, and this is the volume calculation of the ventricles, and the vascularity. You can see that this is the vascularity at 26 and 18, 26, and 31 weeks of gestation. The vascularity inside of the cranium is the very remarkably and rapidly developing. And this is the vascularization at 18 weeks of gestation, and this is 20 weeks of gestation, the normal brain circulation. Now, if you look at those the flows, those flows, the epithelial flow, and those are the 3D ultrasound, and this is the 2D ultrasound. And the 3D ultrasound is the accumulation of the 2D ultrasound. And then this is the HD flow silhouette mode. The silhouette. Therefore, the all of the vessels, they have the translucency. So you can look at the vessels behind this vessel. So sometimes that this is not. I think that this is not so useful in the neurosonography, but in the cardiology, it is very, very useful. Now this is also, the civet. And sometimes, the doors, the vascularity, the visualization of the vascularity is very good and helpful in the clinical world. This is the interhemispheric cyst, therefore this may be the agenesis of the corpus callosum. But here you can see, the because of the vascularization, that you can assume, you can estimate the agenesis of the corpus callosum. This is very typical agenesis of the corpus callosum, very recent case, and there's no corpus callosum here. And here, this is the actual, the actual view, and here this is the parallel anterior horns, in the actual section here, okay? And so, this is the civet ultrasound. And here, this is the 2D ultrasound, and this is the 3D ultrasound. And you can see here the anterior cerebral artery, but no continuous the paracallosal artery. And this is the case, I have the suspicion of the corpus callosum agenesis, because, that there's no corpus callosum at all in the sagittal section. However, here you can see this is the vascularity, and here this is the along with the existence of the corpus callosum. Therefore, that there is not the corpus callosum agenesis, but the very, very hypogenesis of the corpus callosum. Okay. Now, this is the holoprosencephaly. This is the eye, the two eyes, and then here you can see there's no, the separation of right and left hemisphere, and then here you can see those are the vascularization. The vascularization is very honest to the development of the brain. Therefore, that if the holoprosencephaly, that they, those are, if that there are two hemispheres, they are the normal vascularity, but they even in the holoprosencephaly, that those vessels, that this is the called as medullary veins. Medullary veins are very honestly, they're running, inside of the brain. Now, sometimes that we see the normal medullary vein and abnormal, and this is also abnormal medullary vein. So the vascularity inside of the brain is creating and developing very rapid. So that we can compare. If there is a abnormal case, that you can compare the normal case, the right and left, and then compare those of the normal and abnormal. And the bone analysis, this is 16 weeks. You can see the anterior fontanelle, and this is 13 weeks of gestation, cranial bone, the occipital bone and frontal bone, and the parietal bone, that you can see doors from the early pregnancy. And 18 weeks of gestation, vertebra, you can see the vertebra and the rib, and you can see those are the civet ultrasound. So civet is not only for the cyst or water-like or the balloon. The civet ultrasound is sometimes helpful to visualize the bony structure like this. So the spina bifida, here you can see this is the spina bifida's baby, and this is the male meningocele, and this is the bony structure by civet ultrasound. And here you can see this is a real spina bifida. Excuse me. So if you see the bony structure by ultrasound, of course, the classification is very easy to visualize. This is the MRI. MRI, it is very difficult to see the classification. Now, the easy change of the slice, here, this is a tomographic ultrasound imaging. This is very, very, helpful and very useful imaging of the 3D ultrasound. And also, you can change the slice width like this. So, this is not done by, this cannot be done by MRI, and it is very very easy and very very easy to handle, and easy change of the slice width. And this is all of those are the 3D ultrasound ability, the offline analysis without patient. Even the patient is going back home, you can play with the 3D ultrasound image. But it takes the only several several seconds or the several minutes. So I usually just after the acquisition of the 3D ultrasound, I do those things just after acquisition. And the easy comparison to the normal brain, at the same gestational age, here you can see the normal and abnormal. So it is very easy to compare normal and abnormal, because you can get the easy orientation of them. So and then as I told you, the bony analysis is possible, and you can measure the volume. That this is our study. Between 11 and 20 weeks of gestation, intracranial volume, ventricular volume, and coronary plexus volume. And then those are increasing. Of course, there is reasonable, but actually, it is possible by 3D ultrasound. And the one more thing, the good thing, by 3D ultrasound, longitudinal assessment in the same frame. This is a ventriculomegaly at 20 weeks of gestation, and then 20, 21, 24, 29, and 33 weeks of gestation. It is, amazingly, the spontaneous resolution is seen here at this. So, the atrial width is 50 millimeter. Many of you think that, the termination of the pregnancy to the parents. However, I look at, the 1 week, the 1 week later, and then if there's a, the tendency of reduction of the enlarged ventricle, I can say that, the weight can see. And also the longitudinal assessment, the 17, 18, 19 weeks after the SIFD, the one twin died, of the MCDA twin at 16 weeks of gestation. And, the 3 weeks, every week, that I did the transvarsal sonography. And then finally, 19 weeks, the missing of the brain damage is conspicuous. Now, the hydrocephalus, the over 100 genes have been described. And, there are many, many causes, the causal factors behind the hydrocephalus. So sometimes, even the enlarged ventricle hydrocephalus, you have to look at, the vascularity, and then, this might be, the hypogenesis hypoplastic, the corpus callosum there, and then adducted thumb, and this is a male. So maybe you know that this is the L1COM gene mutation, X-linked hydrocephalus. Now, okay, so this is the explanation of the L1COM, the one of the cell adhesion molecules. But I don't want to talk much about those genetic things in this lecture. And this is a big head with a asymmetrical brain, and this brain is very, very abnormal. And this brain, the left brain and right brain, is a very, the big size difference. Right is 42 and left is 23. So, almost double size of the right hemisphere. And here, this is the normal vascularity at the same gestation. And here you can see this is the overgrown vascularity. Okay, so the brain is big and the overgrown vascularity, and inside of the brain, very, very abnormal. And then this is the tumor-like overgrowth skin. So something happened. And this is the PIK3CA gene mutation mosaicism inside of the tumor-like structure and the brain. This is the somatic mosaicism. And so, there are many genes, that are related. And, this is the Joubert syndrome. I don't think, that you have to remember those genes. However, Joubert syndrome is not brain disease. The Joubert is the systematic, and this is the ciliary disease. Okay, so there are now 37 types of Joubert syndrome, and this is genetic disorder of the cellular cilia. And here, this is a cilia, and the cilia is very important organ, anywhere, inside of your body, my body, and of course, the very famous one is a molar tooth sign, of the Joubert syndrome. Here, this is the MRI, but this is the molar tooth sign. Now, we have very early case. This is 12 weeks, here, this is the posterior fossa, the very big, but we don't have any, the confidence to say that this is the Joubert syndrome. And 14 weeks, it might be. However, we don't have the conspicuous confidence. And 16 weeks of gestation. Here you can see, that this is very, very, you can see, this is a very like molar tooth sign. But at that time, we examine the CVS sample, but at that time, we couldn't find the gene, the relating gene. And here, this is the recent one. This is called the slow flow. And this is much more, the powerful one, than it's the flow. And then, this case had the renal multicyst. And finally, we found that, the CEP290 gene mutation, that this is a compound heterozygous mutation that is from father and mother. So, we have to continue to counsel the patient, the next pregnancy. Now, lastly, I'd like to talk about the eyes. This is the cat eyes. But, I'd like to talk about the cat eyes. Here, this is the tomographic ultrasound the image, and here this is the lens, and this is the eyeball, and this is not surprising. The many of you look at the coincidentally, you can see the fetal eye, and this is the silhouette ultrasound. This is the lens, and this is the vitreous body, and here there's something. Here, this is the central canal. And this is the exophthalmos baby at 29 weeks of gestation. And here, this is usually, this is, the lens is inside and the center. However, here, the right hand side and left hand side, you can see the lens is here and there. This is the transient exotropia in the case of the severe hydrocephalus. And here, this is the lens and vitreous body at 15 weeks of gestation, and this is the 16 weeks of gestation. And here, inside of along with the central canal, there is a hyaline artery, in the fetuses. But, the 97% of the mature infants, there's no remnant hyaline artery is visible. So, the hyaline artery is seen only in fetus and premature babies. And here you can see this is 18 weeks of gestation, the hyaline body and hyaline artery. And this is the 19 weeks of gestation, hyaline artery by 3D ultrasound, the HD Live Pro and the HD Live Silhouette. And this is 16 weeks of gestation. Now, the baby's eye, the very premature eyeball at the beginning of 12 weeks of gestation, and 13 weeks of gestation already, the lens and hyaline body is visible. So, from RE 12, middle 12, and 13 weeks of gestation, the eye can be visible. The eyeball is visible, between 12 and 13 weeks of gestation. And we have the HD Live Studio, I just, describe this, the three kinds of lights, and spotlight, point light, and directional light. And those light, the combination of those light, you can, make a very nice shadow, like this. So this is the baby, and here you can see this is the light, and this is the point light, and this is the spotlight, and this is the background light. And so you can put the move those three kinds of lights. However, it is very much the too much during the clinical practice. Therefore, there are several the pattern, and that is saved inside of your your machine. Now, this is 18 weeks of gestation. This is the nostril, the two nostril, and here this is the eyeballs, and lens, bilaterally, and then this is this is lens and the central canal, and here by using HD Live Studio, you can see the two eyeballs and the lenses like the very mysterious the image. And here this is the vitreous body and lens at 18 weeks of gestation, and we can call that the sono-ophthalmology, the fetal sono-ophthalmology. And here you can see this is the 20 weeks of gestation. This is the video. And here, something wrong here inside. Can you see that? And here, not only the central canal, there are several membranes like this. Okay, so this is the unilateral retinal detachment. Okay, so retinal detachment, only the right eyes. Left eye is okay, but the right eye of this baby, the retinal detachment inside of the utero occur. So there are many kinds of the ability and utility and application inside of your the boson. And actually, I don't know, many of you are using the doors application or utility. However, if you use those things rightly, it is very helpful, not only for the making the artistic image, but also for the getting the clinical information. So owing to the various expression of the 3D ultrasound, fetal neurosonography is a powerful tool with several 3D abilities, and it has greatly contributed to the elucidation of the fetal brain mystery. Thank you very much. So if the participants have the questions, it is my good pleasure to talk with you and discuss with you.
Okay, thank you very much, Dr. Pu, for sharing the fantastic information, very, very beautiful of advanced image in the presentation. And okay, I hope you all enjoy this amazing presentation now. Dr. Pu will answer some questions that were sent to during the presentation. Just a reminder, please be sure to type your question in the question box in your control panel at the right hand side. So, doctor, right now we're waiting for the question from the participant. So during